And I'm going to talk to you a little bit today about some roles that geospatial technology can play in sustaining infrastructure. So Bentley defines infrastructure a little bit differently, basically as the entirety of the built environment. So everything ranging from roads and bridges to buildings to offshore structures, railroads, water, power, telecommunications networks. Basically, if it's built, we refer to it as infrastructure. And this infrastructure does not exist in a vacuum. It exists in a geospatial context. And obviously, by taking that geospatial context into account, we can add greater clarity and ultimately greater value to business systems around infrastructure. So when we say sustaining infrastructure, the word sustaining is really a code word for the entire infrastructure lifecycle. So planning and design, construction, operations, and maintenance of infrastructure. And so it's not so much the geospatial information itself that we're concerned with the role and the value it can add to the business systems around sustaining infrastructure. So, for example, Connecticut Department of Transportation is an innovative organization that has really embraced the movement of their systems into the cloud. And what you're seeing here is an example of one of their systems. And it's a great example of integrating an existing information lifecycle management system with a live geospatial context. This is managing projects for the construction, maintenance, operation, and permitting of both linear assets and area assets. And it's a great example of how geospatial context can add clarity to the users of the system and ultimately add value to those users. So, switching gears a bit, you've many times today heard the buzzwords of Internet of Things and big data, but those buzzwords are only as valuable as what you do with the information you get out of them. And that's where predictive analytics comes into play, where we can take information from IT and engineering and operational technology and combine all that information with domain expertise captured in the form of predictive rules to generate actionable information to help you optimize the operations and maintenance of your infrastructure. So one of my favorite examples is this regional water system in Australia. I like it because it combines so many disparate sources of information. They have geospatially located water level sensors to measure the level of water in the various reservoirs. They have geographically correlated information on water demand based on historical data. They have information on electricity prices and how they tend to vary over time. They're also taking into account weather data and weather forecasts, where it's going to rain or where it's not. And they can take all this information to answer very simple questions like, how much water do I need to pump from one reservoir to another reservoir in order to meet the predicted water demand? And when should I pump that water to most cost effectively move it around given predicted energy prices? So predictive analytics, by answering these questions with confidence, can ultimately help them optimize the operation of the overall water system and save them millions of dollars. And they could even do things like set alarms, so when the actual electricity price exceeds the predicted electricity price, an operator can make an informed decision about whether or not to suspend pumping operations. So switching gears again, I want to talk about a very interesting technology that can take normal digital photographs from a handheld camera or from a smartphone, or perhaps a camera mounted on a car, or obviously a camera mounted on a drone, or a camera mounted on a helicopter or airplane, or pretty much wherever you want to put a camera, and can combine all of this information, all these photographs, to produce a multi-resolution, photorealistic 3D mesh that can capture a model of reality unlike anything else. So this is a perfect technology for bridging the gap between geospatial scale, and a BIM scale. Due to its multi-resolution nature, it can capture a model of reality on a scale that ranges from the cracks in an ancient sculpture all the way up to an entire city or even an entire region. And if you need more detail or more accuracy in one area, just take some close-up photos and throw them into the mix. So the ease and cost effectiveness with which these meshes can be generated is really unprecedented. We're talking about an entire industrial site for a few $1,000s, or the entire Paris region, which you're seeing now on the screen. That's 11,000 square kilometers at a ground resolution of 7 to 9 centimeters accuracy for less than $100,000. So this technology is really changing the way that companies do business, where they might once have done a one-time survey to get a very accurate, albeit limited, model of a site. They can now generate these reality models on a almost continual basis, and to get a much richer context and a more realistic view of the site. This is made possible because they don't need to buy a bunch of software and buy an army of drones and hire a bunch of drone pilots, but they're innovative companies that can essentially provide these reality models as a service. So this data can also be integrated with data from traditional GIS and BIM sources. It can be edited for touch-ups or to reflect changes and proposals. And it can be an ideal starting point for traditional modeling. So you can imagine that rather than starting from a blank canvas, you can jumpstart your BIM model with an ultra-realistic context that's got unprecedented accuracy and photorealism. Another great thing about this technology is that it's kind of future-proof in that as photographic sensors advance, and they are all the time, and as computing power increases, you're going to get more and more detailed models in less and less time for less and less cost. So this technology is truly something that can be useful at a geospatial scale of kilometers and even down to the sub-millimeter scale of mechanical applications. So, in summary, I've talked a little bit about how the obvious thing, the geospatial context can provide greater clarity and insight and value to normal business systems around sustaining infrastructure. I've talked about how predictive analytics can create actionable information to help you optimize operations and maintenance. And I've shown you this, what I think is pretty cool technology of these multi-resolution 3D meshes that can be generated from photos in a variety of sources. I mentioned mostly photos, but these can really take in other laser scans and other forms of information into account as well. And I'd like to close with a few words about the bright future. We've talked about all these technologies that are advancing of cameras and batteries and drones, and I think the possibilities are really endless for this stuff. You can imagine someone donning a hard hat, instrumented all around with sensors, doing a walkthrough of a building or industrial facility, and walking out the other end with a reality model that captures in infinite detail everything that they just walked through. You can imagine a domain expert sitting at his desk doing inspections of an offshore oil rig using reality models that were generated from automated drones both below the surface and in the air. And so in the area of big data, it's obvious that we're going to see lots and lots more sensors and lots more data, but I think the next wave really comes when we start utilizing that data we have in a better way. For example, there was an article in Forbes last week that talked about a oil rig that had 30,000 sensors on it, but they were really only using 1% of the data from those sensors because they were just using it to capture anomalies and send up alerts. They weren't really using it to optimize the maintenance and operations of the system. I think in the future, we'll be applying machine learning to the data that we get from those systems to generate more and more insights and ultimately have better efficiency and better operations of those systems and ultimately better safety on that oil rig. So with that, I think the world of sustaining infrastructure has a bright future, and I think these technologies can play a role in that.